So let's look into one of the data here, couple of data actually. So as usual, I'm going to import cbor, matplotlib, right? I'm going to run this. Here I have a data, age, years, and salary. So based on the age, there are salary basically. All right, the whole thing I'm converting into data frame. Right? Run this. This is a simple data frame. Now there is something called a box plot. Box plot. What is this box plot? How to interpret this and how to write this? Whole data frame dot plot. Plot. So this is a standard you can use most of the time, and here you keep changing the type of a graph. Earlier we have seen bar plot, histogram, right? So in short we used to write hist. So here kind equal to box, and I'm defining the figure size here, fig size. So I need 8 and 5. You can change according to your need. And I want color red and white ticks. As somebody asked that question, how to change the numbers, I will talk. This is basically white ticks. I will explain this, don't worry. So what we'll do, we'll execute this. We'll execute this. So here age, years, and salary in thousands. So here we see something different. Some circles here, some rings here, and this is basically, it is difficult to interpret. So basically what happens in the box plot, how it works, it will take your data, suppose say age, years. Take all your data, whatever the data you have, right? And it will sort from lowest to highest. Right? Suppose 100. I'm just taking some numbers. So what it will do from 1 to 100. So it will try to find the 25th percent data in this entire data, right? 1, 2, 3, 4 up to 100. 25th percentage data. Suppose say he in this case 25. Obvious, right? And 50th percent data. Suppose say 50, and 75% data, say 75, and this is a maximum number. So it is going to calculate that 25th percent data, right? 50th percent data, 75th percent data, right? So and minimum number always we will have, and maximum number I will have. So accordingly it is going to plot this. So now let's look into one of them. Let's take on the salary thousands, right? So what is the minimum number we have? Minimum number, say 15, right? 15 is the minimum number. So now you can see that. So I will just join here. 15. This is the minimum. This is the minimum. And what is this line? This line is 25th percent data. And what is this small? This is the 50th percent data. And what is this line? This is the 75th percent data. Sorry, not 750. In a second. Okay. I will show you that with examples, how 25 will be calculated, 50, 75, right? And this is the maximum. And we have some ring here. This ring is basically, we call this guy as an outlier. And why this guy is standing out here? Right? Why this guy is not in this list, or how did it come here all the way? So we'll call it as outlier. What is an outlier? Let me give an example. In your class, say that, right? Say that there are 100 students, okay? There are 100 students in your academics or the diploma or BTech, whatever you can, wherever, whichever background you come from. Say that out of 100 students, most of the students say they are getting marks between say 45 marks to 70 marks, right? Say 99 students. 99 students they fall under this range. Their marks are basically in this range, 45 marks to 70 marks. There is one student who got 100 marks or 95 marks. So here, don't you think all these 99 students will look at him saying that, okay, oh, this guy is really intelligent or whatever you can call him, right? So basically this guy stands out among all these 99 students, right? He's outside this normal students. When I say normal student means he's not handicapped or whatever it is, right? He's not that one. I'm not talking in terms of that one. Basically, he's not as a normal student. He is having some special skills or maybe very smart, very intelligent or whatever you can call it. So he is not mingling with this. He's not in this range. So those guys will be identified. So he is one of that guy. He is one of that guy. He is not in the normal range. So this kind of a data, we call it as outlier. Right? Here we have one outlier. And what is this guy? Below the line. So you can think the same example. There was one student who got only 3 marks. He is again special person, special student. He is also not like a normal. So this guy is far from this range. So that guy, it's a below level, right? So that guy is over here. So these are basically what? Outliers. We will talk more about outliers and how it is being identified. How it is being identified. There is a formula, right? Let me show you that same example here. These are the same data I have used, right? And I'm just going to sort it. Just this is to demonstrate you how this number will be identified, how this line will be identified, and this one, and how these circles, outliers will be identified. So it all happened behind the scene, okay? This takes the data and sorting it. It all happens behind the scene. We don't see that one. So let's take the same numbers, right? So all the same numbers I have just sorted it and copy pasted. I think 20, okay, one number I did not write. Anyway, this is inside this, okay, this markdown, so no worries. So this is the data. So we have how many data points here? I think we have 12, I believe. Sorry about that. We have 12 data. Now what I will do for a 25%. So for that, what I will do, I will first plot this. Okay, again, before that, sorry guys, one point I missed to explain, right? We'll move on to the next point after discussing y-ticks. So this is a y-axis, this is x-axis, right? Y means this side, x means over here. Since we have a string here, we cannot give any, there won't be any 5, 10 or anything. So this range, I'm using this range function. I want this interval should be 5, multiples of 5. What I did, I chosen 0, start from 0, 55, right? And what is this? Step size. So every 5 step, I want the data here, every 5 step. So that's how I can choose this range. So what I will do, I will not give this. I will not give this. By default, it will choose depending upon the data here. It choose 10 multiples of 10, 10, 20, 30, 40, 50. but I'm not comfortable in judging these numbers, right? So I can give my own numbers. So you can see that how range function is, I make use of a Python concept here, right? So if I execute this, you can see 0, 5 and things like that. All right. Okay. So now what I'm going to do, I'm going to take this data. Okay. So here 25%. So when I say 25%, so this is how our box plot looks like, right? So I'm just going to draw this, then we can interpret. This is how it is, right? And here we have this plot. So here 5, 10 and y-axis. So for 25%, it is 25 divided by 100 as usual into n plus 1. Into n plus 1, it comes around 3.25. Right? So 3.25 for sure will not have a position, right? So this is 1, 2 and 3 and we have a 4. So it is this data is in between 20 to 21, around that data. So that data is going to be this 25% data. That is suppose say 20.5, right? So if I go here, this is the right, this is the 25%. You see that almost same 20 point around that point. So that is basically what 25%. So what is 50% data? So this line or this line. So yeah, 50 divided by 100 into n plus 1, right? N plus 1. So 6.5. So 1, 2, 3, 4, 5, 6, and this is the 7th. So somewhere between 23 and 24. Right, somewhere around that. So you can see that if I plot this, it will come somewhere 24, around 24. So let's not be too precise here. So this is the idea I'm trying to give you, right? So then again for 75%, 9.75. So 7, 8, 9, 10. So between 30 to 34. Between 30 to 34. Let's check that one. You can see this 75%, right? Somewhere I think 31 or 32, between 30 to 34, right? So this is the formula it uses behind to find the 25, 50 and 75%. All right, very simple calculation, you don't need to do anything. So this is all basically happens behind the scene. I'm trying to give idea how it works. All right, now let's talk about the outlier. How to find this outlier, right? So for that, I will take one example. I have taken the salary data, right? Let me, this is the salary data. You see this SAL, I have taken a salary, right? Some salary data I have, right? So these are basically some data I have taken. I just gave a name, okay? Don't try to think too much what is 15 or things like that. With some numbers I have stored in sal. So let's try to find this salary. This is basically same numbers, okay? The same numbers. Here I did not give the complete name, that's all. So I have put it in one series, pandas task series, we know that. So here I need to find the outlier. So how it works behind this. Again, this is basically what I said, the formula wise, right? Formula wise, 25%, 50 and 75. If I want to find the 25%, I don't need to do this formula. We have a methods. We have a methods. What is that method? Quantile methods. Quantile methods. We will take this data dot quantile. So how much percentage? I want 25th percentage data. 25th percentage data. Store that in Q1 and print it. If you want 50th percentile, right? SER dot quantile. And guys, 25th percent data we can also call quantile 1. This is a 75th, right? 75th we can call it as quantile 3, and 50th percent is we can call it as quantile 2. Quantile 1, 2, and 3. So how to find this? Using simple method. Formula wise we have seen, but I don't want to do the calculation, so I can use this methods. First 25, third one 75. If you want second one, use a 50. I'm just just taking the data and printing it, right? Let's print this. I will talk about this IQR. All right. So quantile 1. So you see that 20.75. Quantile 3, 31. If I go back, this is exactly 20.75. This is exactly 31. Even we manually we calculated the same. 30 to 34 is what I was saying. It is 31. 75%. So that I can able to see here in this method. Quantile 1 and the 2, if you want to, yes, just change it to 50%. So there is something called IQR, interquartile range. What is this? So this is the box plot. This is the box plot. So interquartile range. This is Q1. This is Q2. This is Q3. Now it is very simple to understand. It is Q3 minus Q1. Q3 minus Q1. This will be limited, and this is basically IQR, interquartile range. Interquartile range. Why do we need this? This will help us to identify the outliers. Identify the outliers. What is the IQR? We figured out Q3 and we figured out Q1, right? IQR is 10.24. We'll take this IQR. So our objective is to find the outlier. Remember, in order to find the outlier, I need a IQR. In order to find the IQR, I need a Q1 and a Q3. All are connected. IQR connected. IQR to Q3, Q3 and Q1. We all need all of them. That's why I'm taking you through all this journey. Fine, I got IQR. So how this circle is coming? How this circle is coming? This is upper side, right? This is the lower side. So upper side, I'm going to use a Q3. This is the formula. Q3 plus 1.5 IQR. We identified Q3 plus 1.5. This is the standard formula, guys. This is not something I cooked up. Okay. So this is the standard. So how this outliers are coming into picture. So 1.5 into IQR. We identified IQR also. So this is the upside data. So let's execute this. So 46.35 we got. So what does it mean? It means that any data 46.37, assume this is a 46.37. Any data above this line is going to be called outlier, right? So let's go back here. In our case, 46.35, right? So you see this, somewhere it is coming here. So not exactly this, this is a reference I'm giving. So somewhere, some number it is going to identify. So anything above that line, above that point, that is 46.37, is called as an outlier. we have only one, right? That is 52. So that's why you see only one circle there. That is only one outlier. And how about this guy? There is one guy, right, in this case. So how this guy will be identified? Same concept. Only thing is, this time, I'm going to take a Q1 minus, because I need to identify this circle, right? So this is a Q1. So I'm taking a Q1 minus, because I have to come down, minus 1.5 into IQR. 1.5 IQR. So this is what I have taken here. Any data below 5.37 is going to be outliers, called as outlier. Right? We don't have any data less than 5.37 in this particular, because I have taken this data. So I don't have any data below 3.7, right? All are in above 15. Minimum itself is a 15. So it is not showing me any outlier at the lower side, right? So that is basically how we can identify the outliers. All right.